Before we get started, let's look into what are agents. Now, agents are systems that are designed to simulate human behavior. When we say simulate human behavior, they'll be good at problem solving, they'll be good at executing tasks, and they will even be good at collaborating in a team, similar to how we work with other people in order to achieve common goals. An agent usually has a large language model, or for that matter, a large vision model, or even a multimodal model at the heart. And what makes the agents special is that they are sophisticated LLMs which are equipped with prior knowledge, or even some sophisticated tools, for example, tools to browse the internet, or in certain cases, even they have observations of their environment. And combining all these things together along with the AI model is what leads to an agent. And the more the system uses an LLM to make its own behavioral decisions, the more agentic it becomes. We need agents because agents have the ability to reason, and they make the LLMs much more sophisticated when it comes to reasoning. They also enrich the capability of reflection. When it comes to answering questions like, the number of hours in strawberry, is because they lack self-reflection. And that sort of problem is solved when we convert them into agents. And then there's tool usage, where the agent enables the models to browse the internet or get additional information in order to respond to any prompt. And then there's always collaboration, where we can have multiple specialized LLMs. And that's why the performance of the agents is much higher than the simple large language model call. So with that information, if we want to look into what are the different frameworks that are available in Python today in order to implement agents, we have CrewAI, and then we have AutoGen from Microsoft, and we of course have LangChain or LangGraph, and these are the main frameworks that are available in the market today. In this video, let's focus on CrewAI, and let's build a small game, which is a well-known snake game, and we are going to involve 3 agents for this. So the first one is going to be a software engineer agent, and that agent is going to collaborate with a QA engineer, and that agent in turn is going to collaborate with a chief QA engineer. And together, these 3 agents are going to write Python code, review the code, and evaluate it so that the game that they have developed is production ready. So without further ado, let's get started. So this is the GitHub repository for CrewAI. We can see that already there are 23,000 stars. And if we scroll down, they're saying that it's a cutting edge framework for orchestrating role-playing autonomous AI agents. It fosters collaborative intelligence. It empowers agents to work together seamlessly, tackling complex tasks. So if you have a complex task and you want more than one agent to collaborate in order to solve that task, then probably CrewAI is the framework for you. Let's look at the documentation as well. In the documentation, again, they are saying that you can build AI agent teams that work together to tackle complex tasks. And it's a cutting edge framework for orchestrating AI agents. So if you have multiple AI agents again, and you want to orchestrate them in order to collaborate, communicate, and work towards a common goal, then again, this is the framework for you. They're saying that just like a company has departments like sales, engineering, and marketing towards achieving a common business goal, CrewAI helps you to create an organization of AI agents with specialized roles collaborating to accomplish complex tasks. And we can see that the agents have innate ability to reach out to another agent to delegate work or to ask any questions. So we can see that there are 3 agents here, and the agent has tools, and these are the tasks. For example, task can override agent tools with specific ones that should be used, and also have a specific agent tackle them. And processes define how agents will work together. It's more like defining workflow, like this agent should hand over to this agent, and this agent in turn should hand over to this agent, and they should work together. So these are the different components in Crew. First comes the Crew. So this is the top level organization, and the key feature is that it manages the other AI agent teams, and it oversees the workflow, and it also ensures collaboration, and it delivers outcomes, something like the manager of a team. And then we have the actual agents that do the work, and these are specialized team members, and they have specific roles. For example, a researcher, a writer, a programmer, a QA engineer. And again, process is the workflow management system, which defines collaboration patterns, and it controls task assignments, and it manages interactions. So you can define how the different agents interact using processes, and tasks are individual assignments. For example, as the task of a software engineer is to write code. So tasks generally have clear objectives and they use specific tools. For example, a software engineer is going to use an IDE and is also going to compile the code, etc., etc. And the tasks feed into large processes and produce actionable results. So with that high-level overview of what's inside Crew, let's get our hands dirty and get started with doing some coding. So let's start with creating a Conda environment. I'm going to create a Conda environment named CrewAI with Python 3.11. So if we run that, it's creating a new environment. Now that it's created, I'm going to activate the new environment. So once we have the new environment activated, I'm going to proceed with the CrewAI installation. So we'll have to do pip install CrewAI. If you want additional tools that comes with it, you also have to include CrewAI tools. I'm going to install all of them. So now that the installation is out of the way, we can now proceed with creating a CrewAI project. We can also verify that it is available by doing pip freeze grep CrewAI. We can see that we have the CrewAI and the CrewAI tools available. We can now proceed with creating a CrewAI project. So to create a project, we need to do CrewAI create crew, and we have to give the project name. So I'm creating the snake demo project because we're going to create a snake game using Crew. So I'm going to run this command. So once we run that, it now asks what model we're going to be using behind the scenes. So the default is OpenAI, but I'm going to use Llama as I would like to run everything free of cost. So I'm going to choose 5 and enter. And it lists the different models that's available. Currently, it's only 2. I'm going to be tweaking this to use Llama 3.2, but for now, let's just give 1 and say we're going to be using Llama 3.1. So it's now created the snake demo project and it has got quite a few files inside it. So let's go into snake demo and find out what's there. We can see that it's got a README, it's got knowledge, it's got pipeproject.toml, it's got source and tests. So let's open VS Code and explore the different code that it has got. So I have opened the project in VS Code. First thing I want to do is change the Python environment. So I will do Shift Command P on a Mac and select interpreter, and I'm gonna choose the environment that we just created, which is CrewAI. So once I select that, this project is going to use that environment. So now that we have set the environment for the project, let's look at some of the important files that are there by default in the project. Under src, we have the crew.py and main.py. So these two are the most important files under the src folder, and we have the .env, which is to configure the environment. And there's a test folder, but that doesn't have any projects. So under the config, we also have the agents.yaml and tasks.yaml. So we'll have to configure the agents in this agents.yaml file, and we'll have to configure our task under the task.yaml file. So we will edit these two, and we will also be editing crew.py. So let's start by going through the crew.py file and see what's there by default. So by default, crew.py comes with these imports. These are the imports that we will be using in every single project, irrespective of the project that we do. So they are imported by default, and we can see that we have agents, we have crew, we have process, and we have task. And there's also corresponding decorators that are imported from CrewAI project. For example, CrewBase is a decorator for the main class that we write. And then the agent is the decorator for the main agent function that we write. So let's go through one by one. We start by writing a class, defining what we are trying to do, and we annotate with the CrewBase. And inside that, we will be importing the configurations, the agent and the task configurations. For the agents, we'll have to define them like this. We'll have to define an agent with a function and then annotate or decorate it with @agent. And the agent has to return an agent object, which is created using the agent class. So we'll have to provide the configuration and we'll have to define whether it's verbose or not. Similarly, we can create many other agents. In this example, we've got the researcher agent and we've got the reporting agent. And there are tasks which are created again by using the task decorator, and function returns a task object. Now that we have seen how we can create the agents and also the task, we'll have to create a crew, which we can do by decorating the crew function with the crew decorator. And inside the function, we'll have to return an object of the crew. To the crew class, we need to provide the agents. So these are the agents that are created automatically by using the agent decorator. And then we'll have to provide the task. Again, they are automatically created using the task decorator. And then finally, the process. So we need to tell the CrewAI framework whether we like to process the pipeline sequentially or in some other hierarchical way. And then we obviously have to say whether we want a verbose output or not. The next option with process is that it can be hierarchical in case you want to use instead. So they've given a link to the documentation in order to decide between a sequential process and a hierarchical process. So that's pretty much the crux of how we can go about using the CrewAI framework. We'll have to define a crew and provide the agents, provide the task, and provide the process, and all the functions that we define for task and agents, we need to annotate with the corresponding decorators. Let's move on to main.py now. So in the comments, they have mentioned that the file is intended to be a way for you to run the crew locally. So we should refrain from adding unnecessary logic into this file. So basically, if we just want to kickstart the crew locally and then see how it goes, we'll have to run the main.py, and there's a run function which kickstarts the crew by saying that snake demo.crew.kickoff, and it'll provide all the inputs. And there is also additional functionalities like training. So if you want to train the crew for any given number of iterations, then you probably will be using this one. And then this replay, which allows us to execute the crew from a specific task. And eventually this test, which is to create execution and run the results. So let's move on to the config files. The agents.yaml is where you actually define the agents. In the default project, there's researcher and there's a reporting analyst. And for the researcher, they've mentioned the role, which is the senior data researcher, and the goal, which is uncovering cutting edge developments in some topic, which can give any topic that you want. And then we need to provide a backstory. It's more like providing a prompt. So you're saying that you're a seasoned researcher with a knack for uncovering the latest developments in, say, the topic, known for your ability to find the most relevant information and present it in a clear and concise manner. Similarly, we define the reporting analyst agent. So we define the role, and we give the goal, and we define the backstory similar to the researcher agent. And in the task, we need to define for each of the agent what the specific tasks are. One is the researching task. We say research task and we give it a description. Conduct a thorough research on the topic and make sure you find any interesting and relevant information given the current year is 2024. And the expected output is that a list of 10 bullet points of the most relevant information about the topic, and the agent is researcher. And for the agent reporting analyst, we define the task as review the context you got and expand each topic into a full section for a report. Make sure the report is detailed and contains all the relevant information. And the expected output is a full-fledged report with the main topics, each with a full section of information formatted as Markdown. And we define this in the task.yaml. Once the class is written in crew.py, and once the agent and the task functions are defined and the crew is defined, and once the different YAML files are defined, we are now ready to run the crew. So this is the default one and the typical outline. But what we are trying to achieve here is game development. Before we move on to game development, let's remind ourselves what we are trying to do. We are trying to define 3 agents, which is the senior software engineer who collaborates with senior QA engineer, who in turn collaborates with chief QA engineer. And then we have tasks, which is to write Python code, review code, and evaluate code. So we will have to implement 3 agents, and then we'll have to implement 3 functions for the 3 tasks. And if we make them work together as a crew, then we have achieved what we set out to achieve. So let's go ahead and do the code changes. So to edit the project, let's start with the agents. Now we need 3 agents, which are the senior engineer, QA engineer, and chief QA engineer. So I have defined 3 of them. I've given them the role, which is the senior software engineer, senior quality control engineer, chief software quality control engineer. And I've given the goals clearly, which is to create software as needed and create perfect code by analyzing the code that is given for errors. And there's a chief software quality control engineer. The is to ensure the code to the highest standard possible. And then there's a backstory, of course, which we say that you're a senior software engineer at a leading tech think tank. Your expertise is programming in Python. Do your best to produce perfect code. Similarly, for the QA engineer, we give some backstory that you are a software engineer that specializes in checking code for errors. You have an eye for detail and a knack for finding hidden bugs. You check for missing imports, variable declarations, missed brackets, and syntax errors, whatever be it. And then the chief QA engineer is going to feel that programmers always do only half the job, so you are dedicated to making high quality code. So with that definition of agents, we have to define the task for each of the agents now. 3 tasks like we saw before. There's the coding task, there's a review task, and there's an evaluation task. For the coding task, we will say that you will create a game using Python, and these are the instructions, and we'll have to insert the instructions here. I will tell you how the game is getting populated when we look into main.py. For now, we can say that the description consists of instruction, and under the instruction, all the instructions are getting filled in or populated. And the expected output from the coding task is the final answer must be the full Python code, only the Python code and nothing else. For example, no description of what's going on in the code. And for the review task, similarly, there is instructions for the game, and you will create a game using Python, and these are the instructions. And the expected output is that you must fill the Python code, only the Python code and nothing else. Similarly, for the evaluation task. And for the evaluation, the instruction is to ensure that the code is complete and does the job that it is supposed to do. So once we have defined the tasks.yaml, we can pretty much move on to crew.py and then modify here and then add the 3 agents that we have created and the 3 tasks that we have created. In the crew.py, it's now time to define the agents and the task. So for the agents, we'll have to define the function with the agent name as the function name, and we'll have to load the agent config. For example, for the senior engineer, we are loading the senior engineer config, and the name has to exactly match that of the agent that we defined here. We can see that the senior engineer defined here, and also here we are saying agent config of senior engineer, and we'll have to return the agent from the senior engineer function. Similarly, for the 3 agents, I've defined the 3 functions and I'm exactly loading the configurations corresponding to them. Next, we move on to the task and we are defining the task. So there's a coding task, we say code underscore task, and there's a review task, review underscore task, and evaluate underscore task. And again, the name of the task here, which is code underscore task, should match the task that we have defined here, which is code underscore task. Similarly, for the review task and the evaluate task. If we match the names appropriately and then define these functions using the agent and task decorators, I don't see any problems with defining the agent and the tasks. So by populating these functions in crew.py, this file is pretty much complete. I have not changed the crew function at all. It's going to automatically take the agents and the task and then create the crew object and return it from the crew function. And one of the other things now is that, in the task.yaml, we said that we're going to be using the game. So we now have to define the instructions for the game. Now we are doing it like this because we can configure the agents to generate code for multiple games if we want. So in our example, we are going to define two games, which is Snake and Pac-Man. So let's look into how we can go about defining the config for the game, or rather the instructions for the game. Let's move on to creating a YAML file to define the games that we will be using or will be generating the code for. For that, I've created this games.yaml file. Under that, we are giving two example games. So first one is Pac-Man, and we're giving an overview of the game, and then we are telling how the maze layout will be, how the player controls will be, and it's going to be a detailed instruction as to how to go about creating the game. And there's also inputs on scoring system. There's a lives and game over situation. So when should the game be over, and how many lives does Pac-Man have, and how to progress on to the next level, and etc, etc. And then we have the well-known Snake game. So for this one, we are again giving the objective and the mechanics of the game. We are defining how the movement of the snake should be, and we are saying how the snake should grow as it moves, and what the food really is that, and we are also giving the rules of the game, and finally we are telling what is the high score, and this is all going into games.yaml. So now that we have defined this YAML file with two example games, now we need to find a way to feed that into the Crew. For that, we need to modify the main.py. So the main.py file came with this run function, if you remember. It comes with these default lines, which is that, input topic AI LLMs, and then to kick off the Crew. So I'm going to get rid of all of that. And all that we are going to do is welcome to the game. And we are now opening the games.yaml file here, and we are reading that into the examples. So because basically those are the instructions for the games examples we've got. And I'm creating inputs dictionary with the game, and I'm loading the example 2 of which is Snake, and it could be example 1 of Pac-Man, but I'm just gonna run it for the Snake game. So I'm just loading that. Remember, this game is what we gave in the task.yaml. So we could see that it's the game variable. So that is going to get populated because we're now saying that the game corresponds to whatever comes from the examples. And that examples in turn is coming from the games.yaml instructions. So all that we are saying is replace this game with the instructions that you get from games.yaml. Once we have written this bit of code, we are now going to kickstart the Crew by passing the input that we have created as the input to the Crew. And finally, we're going to see what the output code that we're getting. And I think we are all set to run the Crew now. Let's see how it works. So I'm going to save everything, and I'm going to go to the terminal, and I'm going to run this one to find out how the quality of the code is, how well the Python code for the Snake game works. So before we kickstart the Crew, we need to amend the code in order to suit the Ollama model. Now, by default, it's going to use the OpenAI model, like we said before. But because we are interested in running Ollama model, there are small tweaks that we need to do. First is to import the chat OpenAI from LangChain OpenAI. Pretty much the way to bypass OpenAI is through OpenAI, unfortunately. So we'll have to import chat OpenAI, and then we'll have to create the LLM model using the Ollama model, which is Ollama / Llama 3.2. And we have to say that the base URL is localhost because our Ollama model is going to be running locally on this port. So we have to mention that here, and then create the LLM. And once we create the LLM object, we need to pass the LLM to each of the agents, telling that, we are going to be using this LLM for this agent. We're going to do that for each of the agents. Now you can see where we are going here. Basically, you can use different LLM models. Say this is LLM1. You can have separate LLMs for each of the agents. But to keep things simple, I'm going to use the same LLM, and we're going to pass the LLMs to the 3 agents that we have created. So on top of these changes, we also have to force it not to use the OpenAI key. And so the solution for that is to import OS, and we say that os.environment of OpenAI API key is something that is not a key. Basically, I've just given an A, meaning that it's not applicable, and this will force the CrewAI not to use OpenAI. and it will be using the local model, which is the Ollama model that we are running. As always, make sure that you have Ollama installed in your machine and you have Ollama model that you mentioned here is running locally, or it's being served locally. And on top of that, if we open the .n file, we need to make sure that the model name also matches that of the model name that we have provided here, which is Llama 3.2, or it could be Llama 3.3 if you're planning to use Llama 3.3. So once these match and once we have done all these hacks, it should work properly with the local Ollama model. So with those configs set, I'm just going to CrewAI run to find out how it goes. It says running the crew, and you can see that it's populated all the instructions, the snake game description, the objective, whatever we gave in the instructions for the game. So it's still running it, and it should be having the code any second now. So it took a while on the Mac because it doesn't have powerful GPU, but it has eventually come up with the final code for the game, which is this one, which is pure Python code. So all that I'm going to do now is copy and paste this code in a file, say snake.py, and I'm going to run it to find out how good the code is. So I've now copy pasted the code in a file named snake.py, and going through the code, I realized that we need to give the first move as input, which is up or down or right or left. So I'm just going to give up and then run the code to see what happens. We can see that it's expecting us to move, and it's showing us the 3S, which is corresponding to the snake, and these dots corresponds to the space in which it can move around, and it also shows the score at the bottom. And that's pretty much the gist of the story. So we have developed a pure command prompt game, which is the snake game, and we can also do the same for any other game just by using the description or the instruction for the game. So to summarize what we did, we defined the agents in agents.yaml, and we defined the task in task.yaml, and we also defined the definition of the games or detailed instruction for the game in games.yaml, and we edited the crew.py in order to include those agents in these functions in order to define these functions for the agents. And we defined the functions for the task, and eventually we started the crew using the crew function that came along with the default project. We didn't modify anything, and we also made changes to include the OpenAI model. For that, we had to change the environment variable OpenAI API key, and we had to set it to some dummy value. And we also had to make small changes or tweaks to read the games.yaml instructions and pass it as input to the crew when we kickstart the crew. And that's pretty much it actually. So it's quite a simple framework, but powerful framework if you want to have multiple agents communicate with each other and do much more complex stuff. So this is part one of this video, which gave an overview of what's possible with Crew. In the next video, let's move on to Flow and find out how Flow is useful when it comes to CrewAI framework. So with that, I'm signing off, and I will see you in my next video. Take care.